All right, so let's start with trigonometry. Now, as far as trigonometry is concerned, I'm assuming you're in someone who's studying in the Cambridge system. So it's either that, as far as A-levels is concerned, it's either that you know all of it or you don't know any of it, right? So if you're an O-level student, so if you're someone who only took math in your O-levels and didn't take add math, there will be new stuff in this video. But if you're someone who did take add math, I don't suppose there will be anything new over here, right? Keeping that in mind, if if you're just coming from O-level math, what you probably know is SOHCAHTOA, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, right? And if this is all that you know of trigonometry, then you probably think that trigonometry is all about right angle triangles and ratios, that if this is theta, then cos theta would be this thing over this thing, then sine theta would be this thing over this thing, right? And tan theta would be the purple over the green. But actually, it would be a healthier relation with trigonometry if you thought of it in terms of circles. And let me tell you what I mean by that by drawing a big unit circle. Okay, let's try to make a better unit circle. All right. A unit circle is just a circle of radius 1. So this is the origin, and anywhere you point at the circumference of the circle, it would be of radius 1. All right. So let's say that I'm walking around the unit circle, so I'm actually walking in the circumference, right? So let's say I walk 30 degrees, right? I end up over here. This will be some point. This is 30 degrees. So the meaning of cos and sine over here actually is that where if you're moving around in a unit circle, then cos theta is actually the x part of your of the point that you're at. So at any point on the circle, the x component of the point will be cos theta, right? And just to show you that quickly, if I drop a line over here, this will be 90 degrees. Since I took this as a unit circle just to make things simpler, this is 1, right? So cos theta is adjacent over hypotenuse. So cos of 30 was adjacent, which is the x component I claim. X over 1, 1 just goes there and, well, does nothing. So cos 30 is just x. Right? And for generally for any cos theta, right? For any cos theta, for any theta you put in, it will give you the x component of that point. And this is the significance of cos. This is what it means. And very similarly, if I talk about the sine graph, talk about the importance of sine, let's draw a new one, right? So sine, like much like cos, is actually the y component of the point. So if you're walking around in a unit circle, your y component, this is y, this is x, your vertical component of your point will actually be sine theta. So if I walk, let's say 60 degrees, right? So this is 60. I end up at over here, right? And just from what I talked about a few minutes back, this will be cos theta, as in the x value will be cos theta. And what I claim is that the y value will be sine theta, right? And just to also show you that quickly, let's drop a line over here. This will be 90 degrees. So sine theta is opposite over hypotenuse, right? Here I took 60, so sine 60 is opposite. I don't know what opposite. This side is the opposite side, and that is also my y component, of course. So opposite over 1, 1, well, does nothing. So sine 60 is the opposite value. And of course, generally for any sine theta, for any theta I put into sine, it will give me the y value, right? So if you think about the sine and cos and tan, and I'll come to tan in a bit, this it's much better to think of it in terms of this. So for example, if you put into your calculators cos of, let's say, negative 225 degrees, right? Now, if you're thinking about it in terms of a right angle triangle, this doesn't make any sense. First of all, what does negative angle really mean, right? In a right angle triangle, what is the concept behind negative angle? Secondly, such a big angle in a right angle triangle, that also doesn't make sense because the biggest angle in a right angle triangle can be this 90 over here, right? So this is the reason why it is maybe much better to think of trigonometry in terms of a circle, right? So here I told you negative to 25 degrees. Well, this is the positive direction. So if you're moving in this, this is anti-clockwise. So if you're moving anti-clockwise, your theta is positive. You're positively rotating. This is just by convention. And if you're moving like this is negative. So what negative 225 really means is that you move 225 like this, right? And you end up at this point right over here. And cos of this is actually the x value that ends up over here, right? So cos of 220 negative 225 is the x value of this point. You turned around negative 225, right? You were walking around the circle and you turned around negative 225, and the x component of this value, the x component of this point, sorry, would be cos of negative 225, right? So one thing that you could also take out of this is cast, C-A-S-T, right? Now, if you let me draw a unit circle first, actually. Unit circle. Okay, so if you've played around with your trigonometric functions a bit, you'll realize that, for some values of theta, sine is positive, for some values tan is positive, for some cos is positive, and some all is positive, right? And this visualization or this concept can also show you very clearly the intuition behind it, or why is that the case. So in your first quadrant, every value is positive, right? In your first quadrant, your any line, any point in the first quadrant will have a positive x value definitely, right? Positive, positive, positive. And any value in the first quadrant will also have a positive y value, right? So positive x value, positive y value means sine and cos have to be positive, right? And then when I go to the second quadrant, right? So let's say I took this angle, right? So this is actually this, I rotated this much. So over here, my y component of this value is definitely positive, but my x component will be a negative value, right? And this is how you can play around and convince yourself that okay, for first quadrant, all of them are positive. For second quadrant, sine is positive. For third, tan is positive. For fourth, cos is positive. And I should come to tan right now because I haven't really talked about tan. And just to give a startup, tan theta, from what you already know, tan theta is sine theta over cos theta. Right. What you would probably already know is that tan theta is opposite over adjacent, and sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse. So sine theta over cos theta would be opposite over hypotenuse over adjacent over hypotenuse. Hypotenuse cancels. So sine theta over cos theta is actually opposite over adjacent. And this is also how you know of tan. So tan theta is actually sine theta over cos theta. Mind the bad handwriting. So if I take the fourth quadrant, right? If I take the fourth quadrant, so in the fourth quadrant, any point I take will have a positive x value and of course a negative y value. So this is why in the fourth quadrant cos is positive and sine is negative. And if I look in the third quadrant, right, if I look in the third quadrant, any point in the third quadrant, right, so if I rotate above 180 but less than 270, so here you'll see that not only is x a negative value, any point in the third quadrant, its x component is also negative and y component is also negative. So this is assuring that cos is not positive in the third quadrant nor is sine. But since tan is sine theta over cos theta, any negative value divided by negative value will be a positive value. And this is why tan theta will be positive in the third quadrant. So for example, if I take anything like tan of 225, this will give me a positive number. Right. And of course, since in the second quadrant, in the first quadrant, everything was positive, so sine and cos were positive, so positive divided by positive is positive. Here, sine was positive, so positive divided by cos was negative, so negative, this will be a negative number. The third quadrant we just talked about. And in the fourth quadrant, the sine is negative and cos is positive, so this will also be negative. All right. So this I've talked a bit about tan, but sine has a nice meaning behind it that it's the y component of the point. Cos has a nice enough name, nice enough visualization behind it that it's the x component of the point. And actually, tan is not just you can think of tan as something more than sine over cos, right? And you probably have heard the word tangent, right? That gives you a hint what tan is actually about, right? So let me draw a unit circle, a unit circle, right? So tan is actually the tangent at a point, right? And what I mean by that is let's say I move some theta degrees, right? And my claim is that this value, this length actually is tan theta, right? So the length it makes with the x-axis, right? So let me go ahead and try to convince you why this makes sense. So let's just drop a line over here. This will be perpendicular. This value is 1 because I took a unit circle, and this value, let me choose a different color. This value is cos theta for the reasons I just explained. Any point's x component will be cos theta. All right, so tan theta is sine theta over cos theta. This would be easier to explain. Tan theta is opposite over adjacent, right? So if I concentrate on this triangle, right? If I concentrate on this triangle, and this is a 90 degree because tangent to any circle will form a 90 degree to the center. So if I concentrate on this triangle and keeping in mind this is theta, then I will realize that okay, opposite, I know what opposite is. It has a constant value 1. So tan theta is opposite divided by 1. 1 is just a useless number here. So tan theta is opposite, right? And this is what I had claimed. Tan theta is this side, right? So if you're looking at this triangle, this is 90 degree, this is theta, and this is the opposite side. So tan theta is actually this length over here, right over here.